In our final video regarding the disk method, we're going to take a look at some special cases, some very interesting things. And so let's look at a couple of those. So our focus has been fully on this idea of the disk method, to find the volume of a solid of revolution over a certain axis of revolution. So let's look at this. One of two. Find the volume bounded by y equals the square root of x plus 1. We're going to add a little something to that this time. X equals 0, x equals 4, y equals 0. We have all of those boundaries. And what are we going to do with it? We're going to revolve about x equals 4. Whew. Again, here's our formula, pi r squared times h. Basically, again, the volume of a cylinder. We're gluing all these cylinders together to make volume of a solid of revolution. Let's draw the picture. If we draw this picture, all right, square root of x plus 1. Instead of starting at the origin, basically that plus 1 is going to bump everything up. Now we're looking at that. Now we also have x is equal to 0. So that is the y-axis. X equals 4 and y equals 0. So I have 4 intersection points, and what that does is it makes that region right there, and I want to rotate that region around x is equal to 4. Something very interesting happens on this one. See, what happens is we don't need this curve for the whole thing. See, what we need to do is we need to split this up right here. Now, we have to ask ourselves, are we going with the vertical axis or horizontal axis? The vertical axis. Therefore, everything needs to be in terms of y. Now, let's do the easy part first. Let's do this piece down in here. Now, this is basically, it's already a rectangle. So how long is this rectangle from the y-axis out to the number 4? Well, it is just that. It is 4. And this rectangle is going to happen from 0 up to the number 1. Why 1? Well, because if you put 0 into the function, you get 1. Therefore, the first part of our formula, that red portion down in here, is going to be pi times the integral from 0 to 1 of 4 squared with respect to y. Why 4? Because that's the radius. That's how long this is. We didn't need the function, the square root of x plus 1. Now we do. So to do this last part of it, I'm going to have to add on another integral. From pi to 1, but I got to figure out what this is up here. Well, if I put 4 in to the function, the square root of 4 is 2. 2 plus 1 is 3. So I'm sitting right up here at 3. Therefore, that is my other boundary. Now, because I'm in terms of y, I need to rewrite y equals the square root of x plus 1, so it is in the form x equals. To do that, I'll take 1 away and square both sides and get there. So here's what I need. I need to figure out how long this piece is right here? Well, this part between the y-axis and the curve, this part right here is actually y minus 1 quantity squared. That's the area under the curve with respect to the y-axis. I'm going to do this for a second. See that? Area under the curve with respect to the y-axis. If I rotate things 90 degrees. That's the reason why, no pun intended. Okay, maybe a little. So, how long is this? Well, from the y-axis to 4, it's 4. I don't want 4, and I don't want y minus 1 quantity squared, so what I'm going to have to do is I'm going to have to do 4 minus the quantity y minus 1 squared, and all of that is squared with respect to y. That's my formula. A little bit more complex. Again, this is the disk method. That's important because the region is fully touching the axis of revolution. Vertical axis needs to be with respect to y. Let's take a look at one that's a little special to me over a horizontal axis as we close up the disk method. This time, find the volume bounded by y equals the square root of x plus 1. The plus 1's outside of the radical. X equals 4, y equals 1. Those are the fences. Revolved about y equals 1. Find the volume bounded by y equals the square root of x plus 1, x equals 4, y equals 1, revolved about y equals 1. That's the first thing we do, draw the picture. If we don't have a picture, this is very, very difficult to do. So let's draw the picture, let's draw the fences. Square root of x plus 1, something like so. X equals 4, y equals 1. This is the region we want to rotate, and we want to rotate it around the line y equals 1. And if you'll notice, this region is fully touching the axis. So this time, our rectangles are right here, between 0 and 4. But notice I've bumped the axis up. So I want you to think about what's happened. We're going to have pi. We're going to integrate from 0 to 4. But what do we have to square? Well, it has to be with respect to x because this is a horizontal axis we're rotating around. Well, normally this is what I would want. Normally, I would want the square root of x plus 1 because that would be the area under the curve. But that would be from the x-axis to the top. So basically what I've got to do is I've got to take this little chunk away right down in here. Well, this gap is 1. So if I formally wrote out the formula, this is what I would write. It would be the square root of x plus 1. That's the length from the x-axis all the way to here. But I got to get rid of part of it, don't I? I got to get rid of that gap, that minus 1. All squared with respect to x. So what have I just done? Well, if you simplify that, the plus 1 and the minus 1 actually cancel out. If we look at this a little closer, this formula is basically the same as what we did way back here. Take a look. Same thing. Just how we phrased it, just how we worded it, everybody. So that gives you a look at the DISC method. And there are many things that you can use with this method, and we've just touched on some of the main ideas. We could spend weeks going through different scenarios, but basically what you see is what you're going to need to be successful with this. And so you have to kind of think of a way that's going to make sense in your mind. You've got to practice this. And so we will work on practice with the DISC method, because guess what? This is not the only way that you can do volume of a solid of revolution. There is what is known as the washer method. There is also what's known as the DISC method, or the shell method as well. Thanks for watching this video series over the DISC method. We'll see you again soon.